Good evening. I'm going to give you a brief introduction to the greatest common factor and least common multiple of monomials. I understand that we've done GCF and LCM of just numbers in the past. Today we're going to toss in some variables to that process. So if we look at the greatest common factor here, that will be what we consider the highest number, the greatest number, that divides exactly into two or more numbers. So if we look, let's consider the numbers 12 and let's say 28. Just something that we've seen in the past. The greatest common factor, all right? If we look at the factors of 12, we have 1 and 12, 2 and 6, 3 and 4. We have 1 and 28 if we look at 28, 2 and 14, so 2 is a common factor, 3 isn't, 4 and 7. So if we look at all of the common factors of 12 and 28, the greatest is 4. So the greatest common factor of 12 and 28 is 4. Please notice that the GCF will always be at most the lesser of the numbers. Running out of room there. But the GCF will always be at most the lesser of the numbers. So the greatest common factor is something that will be less than the two given numbers. If we take a look at one more example here, let me erase this one to kind of illustrate that point we just talked about. Let's go with the GCF of, let's say, 15 and 45, for example. So if we look at this, the greatest factor of 15, we have 1 and 15, 3 and 5. So the greatest factor of any number is that number itself. Just like in 45, we have 1 and 45. And then we have 3 and 15. And then we have 5 and 9. But if we look, 15 would be the GCF of 15 and 45. It could never be anything greater than 15 because then it would not be a factor of 15. The factors of a number are always less than that number because they're what are multiplied together to get that particular number. So, least common multiple. It's the smallest non-zero number that has a multiple of 2 or more numbers. So let's take a look here. Let's use 3 and 7, for example. And we list the multiples of 3. We just count by 3. 3, 6, 9, 12, 15, 18, 21, 24. Let's stop there. Let's see what 7 gets us. If we count by 7s, I go 7, 14, 21, 28. I'm looking here for common things. There's no 7s up top. There's no 14s, but we do have 21. So that is the smallest. That's the least number that has a multiple of 2 or more numbers. It's the least when it's a multiple of both 3 and 7. Okay? The LCM will always be at least the greater of the two numbers. And I'll illustrate that here in a second. Okay, it will always be at least the greater of the two numbers. Okay? So let's go ahead and illustrate that. Let me erase again this first example. And let's say I gave, let's go with the numbers 4 and 16. So we'd have 16, then 32, then 48, then 64. If we went with 4, we have 4, 8, 12, 16. So our original two numbers are 4 and 16. I look here, LCM is 16. So that's how we do the least common multiple, greatest common factor for numbers, which is what you've already done. Now we start to toss in all these variables. These are the only two examples we'll show tonight, and we'll go through this process together. And we have a little follow-up tomorrow with this stuff. So if we look at the GCF of 4x squared y z to the fourth and 14xy cubed z squared. If we start with 4, 4 is 2 times 2. And then we have x times y times z and z and z and z, 4 z's. Okay, so that is the factorization of 4x squared yz to the fourth. 14, we'd have 2 times 7 times x times y times y times y times z times z. So we factored everything out there. Now typically once we start practicing these, you won't have to show these. There is a pretty handy shortcut that you'll see. You might even see it after this one, but let's talk here as far as common factors. Let's start with the numbers. I have a 2 and a 7, and I have 2 2's. That tells me that I'm going to keep the 2. Okay, so I'm going to have 2. That's the greatest common factor of 4 and 14. I have 2 x's and I have an x. Only guarantee of being in both is 1x. I have y times y times y. I take one of those each. Okay, I forgot to circle the x up there. And I circle 2 z's down here. That means I circle 2 up there. So I would end up with z squared. So the greatest common factor of those two terms is 2xy z squared. If you notice with the variables, we take the lesser of the exponents. When I compare x squared and x, we take x. When I compare y and y cubed, we take y. When we compare z to the fourth and z squared, we take z squared. That's for the greatest common factor. Okay, we're going to take the lesser of those things. Let's talk about the LCM of almost the same thing. So let's take the top here. We'll have 2 times 2 times x times y, z, z, z. Then 7's a prime number, so it's going to be here. Then we'll have x. Then we'll have y times y. Then we'll have z times z times z. As we look at these, let's start with the variables. I have x and x and x, and we're looking for multiples. You cannot have, x cannot be a multiple of 2x's, so we have to take both x's there, so we'll end up with x squared. Same thing goes with y. I cannot just take one of them, I have to take both, so I'll end up with y squared. And z cubed, z and z to the fourth. Z to the fourth is a multiple of z cubed, but z cubed is not a multiple of z to the fourth, so I have to take all 4 from up top here, so I end up with z to the fourth. So if you notice with the variables in that one, we took the greater of the exponents for the least common multiple. So we'll summarize this tomorrow. Let's take a look at the number here. We have 2 times 2 and 7. We have nothing in common there. If I just took 7, 7 is not a multiple of 4. What we actually have to do here is we have to take all of this. The least common multiple of 4 and 7 is 28. this would be the LCM of those two numbers. As we look at these, the LCM, those values, the constant or the exponents are going to be the greater one, and for the GCF, the constant and the exponents are going to be the lesser ones. That's the most important thing to remember, and again, we'll see that with some practice tomorrow, and we'll go from there. See you tomorrow.